Hi everyone, this is lesson 4, connecting multiple representations of limits. You'll notice we have two learning targets for today. I can create analytic, graphical, and numerical representations of limits, and I can identify key mathematical information presented in an analytic, graphical, and numerical representation of a limit, and translate that information to a new representation. So really all we're going to be doing is we need to be able to take limits from either numbers or graphs and translate them back and forth. This is something that appears a lot on the AP exam. So we're going to take a look at number 1. We are told that we want the limit of f of x as x approaches 3 from the left to be infinity, and the limit as x approaches 3 from the right of f of x to be negative infinity. So when we take a look at sketching this graph, the first thing I want to do, and actually this is going to apply for all of our graphs, your graph that you create must be a function. So I want you to take a second and go ahead and write that down because that is going to be important. All right, it must be a function, which means it must pass the vertical line test. So if you were to take a vertical line and drag it across your graph, that vertical line should only hit one y value at a time. Okay, we can't have multiple y values for one specific x value. That's what it means to be a function. So if we wanted to make a sketch a possible graph of what's going on here, the first thing that we really need to pay attention to is what's the x value that we care about. So in this case, we're looking at the limit as x approaches 3 from the left and from the right. So the important x value that we're paying attention to is 3. Then we want to think about what's the y value that we're trying to pay attention to. In this case, our left limit is going off to a positive infinity, and our right limit is going off to a negative infinity. So if I wanted to start sketching my graph, I know that the important x value in this case is positive 3. And so I'm going to go ahead and label that because I know that that's going to be important. And I know that the y values I need to pay attention to are a positive infinity, so that's all the way up at the top, and a negative infinity, which is all the way down at the bottom. Now, hopefully, you guys can look at this and you can recognize that if I'm going to be approaching either positive or negative infinity, then there must be a vertical asymptote. So if I draw this vertical line at 3, if I want to be approaching positive infinity from the left side, then what that means is on the left, I need to be going up this direction. And on the right side, I know that I need to be approaching negative infinity. So on the other side of my vertical asymptote, I'm going to go ahead and draw an arrow going down. Now, both of these arrows that I've drawn are not my graphs, right? All I've done is really just kind of draw what I know this limit is telling me. Okay, and again, I know that I'm going to have that vertical asymptote there because at a specific x value, my y values are approaching positive and negative infinity, which means they're shooting up either really high or all the way down in the negative direction. And remember, that's what a vertical asymptote does. As you get closer and closer to a vertical asymptote, it starts to push your function values either up or down. So now all we need to do is just draw in the rest of the graph. Now again, it must be a function and it must follow this limit that we were given. Other than that, you've got some freedom here. All right, so I think what I'm going to do is I'm going to say, let's put in, this is going to come down and I'm going to make it have a horizontal asymptote at 0. So I'm going to say that it approaches like that. And then if I come from the other side, now I need to think about what else is happening, and I'm going to have this horizontal asymptote here as well. And so all I did was really, the key part that I need to pay attention to is that my left limit is infinity and my right limit is negative infinity. And that's really all I have to pay attention to on this one. I hope that that makes sense. So now we need to take this and write a verbal, description of what's going on here. So in this case, we know that the graph of f of x has a vertical asymptote at x equals 3. So when we look at this limit here, the important part is that we get this vertical asymptote. And that's because our y values are shooting up to positive and negative infinity around this specific x value. So because x is approaching a specific number from both sides, and our y values are approaching positive and negative infinity, we get this vertical asymptote. Let's take a look at another one. Again, we need to first identify what are the important x and y values that we're looking at. So we're looking at the limit of f of x as x approaches infinity is 1, and the limit of f of x as x approaches negative infinity is also 1. So the important x values that we're going to be looking at in our graph are positive and negative infinity. The y values that we need to pay attention to both happen to be 1. So I'm going to go ahead and make my coordinate plane. And I know that my important x value here is going to be this positive infinity, which is all the way on the right, and a negative infinity, which is all the way on the left. The important y value that I need to pay attention to is positive 1. And so I know that whatever's going on all the way over on the right side of the graph, my y values have to be getting close to 1. And so as I go towards the right, my y values need to almost start topping off at positive 1. Which means there must be a horizontal asymptote that's stopping my function from growing anymore. In this case, because I came from the bottom. I could have gone from the top as well, which just means that horizontal asymptote is stopping it from getting any lower. We have a little bit of freedom here, which is kind of nice, but can also be confusing. If we think about our second limit as x approaches negative infinity, so as x moves to the left, the y values again are approaching 1. So what that must mean then is it must also be a horizontal asymptote on the left side. And so all I'm going to do, I'm going to go ahead and connect these two, and I don't know, I'm going to make it look like that, although that was a really bad connection there. There we go. So now I can see that my as I go to the right, my y values are approaching 1, and as I go to the left, my y values are approaching 1. Now again, you have some creative freedom here. You could have made this be above the above the horizontal asymptote instead, as long as your limit towards infinity is 1 and your limit towards negative infinity is 1, you get some freedom there. But the thing we need to pay attention to is as my x values get bigger and bigger, my y values get close to 1. As my x values get more and more negative, my y values get closer and closer to 1. That's what this limit is telling us. So in this case, our verbal description would be that the graph of f of x has a horizontal asymptote at y equals 1. So because x is approaching positive and negative infinity, and my y value is approaching a specific number, my graph has a horizontal asymptote. So you'll notice both of these limits that we looked at just now had something to do with infinity, whether the x's are approaching positive or negative infinity or the y values are approaching positive or negative infinity. It means that we have some type of asymptote on the graph. Okay? Moving on to number 3. Again, let's look at what x values we're approaching. So in this first one, the limit of f of x as x approaches 2 from the left is 4, and the limit of f of x as x approaches 2 from the right is negative 5. So the x value that we're looking at is 2, but we're just looking from the left side and the right side. For the y values, 4 is going to be important, and negative 5 is going to be important. Both of those are the answer to my limit. Those are both y values. So if I start to sketch my graph, x equals 2 is important. And then I have a y value of 4 and negative 5. So let's see, 4 is right here, and then negative 5. Now, I know that my left limit, so let's focus on that first. The limit as I approach 2 from the left has to be 4, which means the first thing I'm going to do is I'm going to put an open circle at the point 2, 4. And the reason I'm going to put an open circle right now is because I don't know if that's the function value or not. I just know that from the left side that it looks like the function value should be 4. So then what I'm going to do is approaching from the left side, I'm going to just go ahead and draw this line right here. So I'm going to just say that was a line segment, and for whatever reason it just stopped there. But I can see then as I approach x equals 2 from the left side, my y value is approaching 4. So I know that that matches the first limit that I was given. Oops, sorry, a little bit too much undoing there. There we go. Okay, then let's look at our second limit there. The right-sided limit is negative 5. So what I'm going to do is I'm going to go to the point 2, negative 5, and again, I'm going to put an open circle because I don't know if that's actually the function value. I wasn't told. So as of right now, I don't know the function value. What I do know is that as I approach 2 from the right side, my function value is approaching this negative 5. And so what I'm going to do is I'm going to say maybe this is a parabola, half of a parabola. But if we look as we approach 2 from the right side, our y value is getting closer and closer to negative 5. So that matches the second limit that we were given there. Now you'll notice I didn't put a closed circle anywhere on this graph. I wasn't told what the function value was. What this means is this could be my graph, or one of those open circles could be filled in, or there could be a closed circle somewhere else on the graph. There are a lot of different options here, but the important part is that we need to acknowledge what these two limits said. From the left side and from the right side, we were not approaching the same value. And so what this means is the graph of f of x has a jump at x equals 2. If your left and right limits don't equal each other, then somehow there's a break in your graph. Okay, and so we call that a jump. Okay, on this next page, you'll notice there are 7 limits here that we have to take into consideration, and we want to make one graph that matches all of these limits. And so I want to make another note here. Remember, it must be a function. And so you want to make sure none of your y values repeat. Okay, so the first thing I'm going to do is I'm going to figure out what are my important x and y values. So I'm going to focus on my x values first. For this first limit, we're looking at the limit as x approaches 1, and you'll notice that's a two-sided limit. So that means from both sides of x equals 1, we need to be approaching a y value of 2. Now we also have x approaches infinity equals -1. We have the limit of f of x as x approaches negative infinity is 0. The limit of f of x as x approaches 5 from the left is infinity. The limit of f of x as x approaches -2 from the right is infinity. The limit as x approaches 5 from the right is infinity. And the limit of f of x as x approaches -2 from the left is infinity. So I'm going to make a quick note here. My important x values then are x equals 1, x equals infinity, x equals -infinity, x equals 5 from the left and the right, and x equals -2 from the left and from the right. So those values are all going to be a part of my graph when I do this. And then my y values that I need to pay attention to are going to be 2, -1, 0, infinity, -infinity, infinity, and infinity. So I'm going to go ahead and start making my graph here and start to think about what this might look like. So my important x values, I have to go at least to 5. 1, 2, 3, 4, 5. And really, we're going to be going off to infinity. And then I know that I need at least to have a -2 and a negative infinity. And for my y values, let's see. We're going to 1, 2, 3, and then let's go -1, -2, and -3. So we're going to need something important at 1 for my x value, something important at -2, 5, 3, 4, 2, 3, 5 is right here. Infinity we know is all the way off to the right. Negative infinity is all the way off to the left. And then let's think about those important y values. We know there's something important going on with a y value of 2, something important going on at -1, something important going on at 0, and then something important all the way down at negative infinity and all the way up at positive infinity. All right, so let's start to take a look at what this might mean in terms of our graph. Let's use a different color here. So for that first one, the limit as x approaches 1 from both sides has to be 2. So what I'm going to do is I'm actually going to go ahead and put an open circle. Oops, that wasn't what I wanted there. Sorry about that. I'm going to go ahead and put an open circle at the point 1, 2. And I know that whatever's going on both sides, it needs to connect at that point there. As x approaches infinity, we know we're approaching -1. And since x is approaching infinity, this must mean there's going to be a horizontal asymptote at y equals -1. So over on the left-hand side, somehow, oh, I'm sorry, not the left side, the right side. Sorry about that. As x is approaching positive infinity, I know that my y value is approaching this -1. So I'm going to draw just a little piece of the graph right there. As x approaches negative infinity, that means this is giving us another horizontal asymptote. And so this one is at 0. So as x gets more and more negative, my y values are approaching 0 over here. Then I can look at this next piece. And this is a lot, guys, so just bear with me. I know this is a lot. As x approaches 5 from the left and as x approaches 5 from the right, my y values are approaching infinity. This is telling me there's a vertical asymptote at x equals 5. So I'm going to go ahead and draw in a vertical asymptote. And on the left side and on the right side, my y values are approaching positive infinity. And so I know that that's what's going on there. Then if I look at this next portion, x is approaching -2 from the left and the right, and my limits are infinity and negative infinity. This is another vertical asymptote at x equals -2. So I'm going to go ahead and draw that in. My right-sided limit is going to negative infinity. So on the right side of that line, I need to be going down. And on the right side, or I'm sorry, the left side, I'm approaching positive infinity. And so I must be going up. Now you'll notice all I've done is draw a bunch of arrows and pieces of a graph. Now I need to actually connect it and make my graph. So I'm going to start all the way on the left-hand side. I can see that I have this arrow pointing towards infinity, towards negative infinity for my x values. I'm going to go ahead and connect that to this next piece here. So that's the first piece of my graph. Then if I jump to the other side of -2, I know I have this arrow pointing down. I know I have this limit must be 1 or 2 right there. And I know that I have this arrow pointing up right here. So I'm going to just go ahead and connect all those. I'm going to go here and then come over this way. And then the last piece of my graph is on the right side of 5, this arrow pointing up. And I need to look at my end behavior over here. This is approaching -1. All I'm going to do is connect those as well. So you'll notice I took each piece here and I kind of drew what was going on at those specific values, and then I just kind of connected them. This is hard. This is a lot of stuff. I completely understand that. So whatever questions you have, please have them written down. Let's talk about it. Let's do it. I promise you can do this. It just takes a little bit of time to really start sketching your own. And I promise it does get easier, and I'm here to answer any questions you guys have. All right. Thanks for watching.